Okay, so today we're going to be talking about applications of quadratic functions. This is going to be where we really see quadratic functions in action, in real life. Okay, now I'm going to go quickly through this. This is going to be a lesson with a lot of use on the graphing calculator. So you need to be able to use your graphing calculator to get as much information about a specific quadratic that's going to give us the information we need. You need to read the entire problem, reread it if necessary. I suggest at least twice. You need to make sure that you understand the question and see what it is that you need to find. Make sure that if you're looking for a max or a min, you find the vertex. If you're looking for a height of 0, you're looking for an x-intercept. Make sure that you define your variables. Draw a picture if you can. Make sure that your answer makes sense with what the question is asking you. Make sure that you finish your solution with a concluding statement so that you put your numbers and your results in context that makes sense. Because otherwise, what's the point of the word problem? So, let's dive in. We've got a model rocket that's being launched from the roof of a building. So I have a building here drawn, and I show the rocket being launched from the top of that building. Okay, we're given the function, negative 5t squared plus 30t plus 10, where h is going to be the height of the rocket above the ground in meters, and t is the time after the launch in seconds. So I want to know what's the maximum height. So we've talked about this before. When I want to find the maximum height of something, I need to use the axis of symmetry to get the x value. In this case, it's going to be seconds. So I want to know at how many seconds, after how many seconds from the initial launch, is this rocket going to reach its maximum height. And when we do that, when we find the axis of symmetry, we take the a term and the b term, we substitute them into the formula, we're going to get 3 seconds. So at 3 seconds, this rocket is going to reach its maximum height. So I need to take that and evaluate the 3 seconds into my function, which is a function of x. So when I plug it in for 3, what I'm going to be getting back is the height. So when I do that, I get about 55 meters, which is the maximum height. That's going to give me the vertex. If you want to graph it, you're going to find an approximation. So anytime you use the calculator to do your calculations, it's going to be an approximation. So you're going to be approximately correct. So just be aware of that anytime you use your graphing calculator to find vertex, to find x-intercepts, anything, it's always going to be approximately correct, never exactly correct. Now, the next one, we have a rectangular field that's going to be fenced on all 4 sides. There's also going to be a line of fence across the field. So here's that extra line of fence. Okay, we've got the fencing here, here, and here. And I want to know the dimensions of the field that are going to give us the maximum area, and I want to know what is that maximum area. So I need to think, if perimeter is when you add up all the lengths and the sides, if that's what perimeter is, then that means that I have 3 widths. I have a width here, and a width here. If I add those 3 together, and then the 2 lengths, I'm going to get a total of 900. So I need to be able to solve for one of those variables, because what I need to find out is how can I make a quadratic out of this? Well, since we're finding area is just length times width. So if I know one of those variables, I can use it to get a nice quadratic. So what I did here in the first step was I say, okay, if 900 is the total perimeter of fencing, and I know I have 3 widths and 2 lengths total, doesn't matter however much the width is or how much the length is. I have 3 widths and 2 lengths. When I add them up, I'm going to have 900 meters of fencing. So what I did was I solved for the width. You can solve for the length. It really doesn't matter. I subtracted the 2 lengths and divided by 3 to get the width. So this is how much one width is going to be. So I use that in the second step here for area. I know that if I take the length and multiply it by the width, which is a function of L, I'm going to get the area. So I take this length and times it by the width, and I get a quadratic because area is squared. I simplify it nicely over here in step 3. And then what I do is I graph it. When I graph it, I look for the vertex. What is the maximum? Here, because I have L, okay, I'm using L in this function. It's a function of L, that's length. The maximum length is going to be about 225. That's where this 225 and this 225 come from. The maximum area is going to be about 33,750 meters squared. Now, how did I find out what the remaining width was going to be? Well, all I did was I substituted in what is the length here. So the length 225 and the length 200 and this length of 225, you add them together, you get 450. You take that away from the total perimeter and divide it by the 3 widths that you have. You have 1, 2, and 3. And you're going to get a width of about 150. You can double check. Put 150 in for all 3 widths, 225 in for the 2 lengths, add them up, you get 900. Okay, so the dimensions of this field are going to be 225 meters by 150 meters, and we know the maximum area is going to be about 33,750 meters. This one is probably going to be the hardest type of problem you need to find because you have to take into consideration 2 things, perimeter and area. You need to use both of those to come up with your quadratic. This is going to be the hardest type of problem. There is one similar on your test. So, moving on. From this point, I use a lot of the graphing calculator to help me to understand the information. So here I have a water balloon being thrown into the air with height h and meters m after t seconds. So they give me the quadratic. How high is the balloon after 1 second? Well, if t is seconds, you plug in or substitute 1 for the t, and you get about 24.5 meters. Now, how long is the balloon more than 30 meters high? Well, if I want to know what is the range of time, that's going to be the width of the parabola when the height is at 30. So think about it this way. If right now the maximum height given, so think about it this way. If I slide the function down 30 units, that's going to bring the range of x values that I want down to the x-axis. And then all I have to do is find the 0 on the left and find the 0 on the right. The range of those 2 zeros is when you subtract them. So if I subtract this approximate time of 4.15 seconds and subtract about 1 second and 35 hundredths, I get about 2.8 seconds. So that balloon's going to be 30 meters above 30 meters for about 2.8 seconds. Okay? You need to start thinking about this more logically. Okay? I'm giving you harder problems in the notes to help you to get the concepts down. Now, in part C, you want to find the maximum height of the balloon. So you need to find the maximum, and you get about 39.6 meters for the maximum. Now, I want to know, when's the balloon going to hit the ground? When's it going to pop? It pops when it hits the ground. So when will that happen? What is the zero here? The zero is about 5.6. And if you notice, the y value is not exactly zero. It's pretty close to zero, but it's not exact. So all of these answers are approximations. You're approximately correct. For the purpose of this lesson, that's okay. Next problem. We've got a soccer ball that's being kicked into the air. Again, height is in meters, t is in seconds. So I have this equation. I forgot to put an x in here. Okay, I want to know how high is the ball after 1 second. We're going to do this exact same thing. After 1 second, how high is the ball going to be? About 20.6 meters. What is the maximum height of the ball to 1 decimal place? Again, we're looking for the vertex. The maximum height is about 31.6 meters. So when does the ball reach the maximum? The key here is when. I'm looking for the seconds. The seconds is about 2.5. And when does the ball hit the ground? Again, this should be a D. Okay, and an S. When does the ball hit the ground? Is going to hit the ground over here after about 5 seconds. Okay, that's it. Go work on your classwork. If you have any questions, please feel free to ask. Feel free to rewind the video, and see you next time.